Okay guys, I hope you're ready to go over the next several problems on the Accuplacer exam with me. So we are going to be going over problems number 8 through 16. So like I always do, I want to make sure that you guys have your pen and paper ready to take notes. And then when you guys have any questions, just please let me know in the comment section. Before we move forward, I just want to say congratulations to all the students who have been messaging me saying that they've been passing their Accuplacer exams and their TSI2 exams. I'm super proud of you guys. So let's go ahead and start with problem number 8. It says, which of the following fractions is equivalent to -6 minus -9 over 8? Okay, so the first thing I want you guys to notice is that there is a negative and a negative right next to each other. Anytime a negative is right next to a negative, they just become one giant positive sign. So now the equation should read -6 plus 9 over 8. Okay, so again, anytime a negative and a negative are together, they become a plus sign. And now you've simplified the problem to what we see here. Now we have to go ahead and take care of this top portion. I know that there are some students that struggle with adding positive and negative numbers. So I just wanted to be able to show you guys what it is that trick that I use or a trick that I recommend. When you're adding a positive and negative number together, ask yourself, what number is larger? Is the negative number larger or is the positive number larger? So the negative number is 6, the positive number is 9. 9 would be the larger number. So because it's a positive number, my answer is also going to be positive. And now I'm going to say, okay, well, how much larger is 9 than 6? So 9 minus 6 is 3. So my answer is going to be positive 3. So -6 plus 9 is positive 3. And then we're going to keep it over 8. And our answer is going to be B. For the students who said, okay, that was super simple, then go ahead and go to my next problem, problem number 9. For students who just want to see one more example of me adding positive and negative numbers, here's one for you. So if I have -10 plus 5, and I'm trying to figure out, okay, what should my answer be? I'm going to ask myself, again, which number is the larger number, the negative number or the positive number? So we see that the -10 is the larger number, so my answer is also going to be a negative. Then I'm going to say, okay, how much larger is 10 than 5? So I'm going to say 10 minus 5 is 5. So my answer is going to be -5. I hope this allows you guys to be able to answer any questions that come along with positive and negative numbers. Okay, question number 9. It says, water runs from a pump at a rate of 1.5 gallons per minute. So I'm going to write this. Anytime I see per minute, I know that we're talking about rates. Whenever we're talking about rates, we're usually going to put in a fraction. So I'm already going to get started. 1.5 gallons. And when it says per minute, that means per 1 minute. Okay? And then it says at this rate, see, we're talking about rates, so it's a fraction. How long would it take to fill a tub with a 150-gallon capacity? So they're giving us more information, and so it's not just going to be one fraction, it's actually going to be a proportion. A proportion is when you set two fractions equal to one another. The trick in doing a proportion the proper way is whatever you put on the top has to remain on the top. So because we put gallons on the top in this second fraction, we also have to put gallons on top. So we're going to write 150 gallons on the top. And so on the bottom, we're going to leave in minutes. But we don't know how long or how many minutes it would take yet. So we're just going to put X. So now that we have two fractions set equal to one another, we're going to go ahead and solve for X. The simplest way to do this is to do the butterfly method or to cross multiply. So we're going to go ahead and do that. 150 times 1, bring down the equal sign, is equal to 1.5 times X, which is 1.5X. Then we're going to go ahead and just multiply it out. 150 times 1 is 150, is equal to 1.5X. Now the goal here is to isolate the X or to get the X by itself so we can see what the X is equal to. In order to get the x by itself, we have to figure out, okay, what value is causing the x to not be by itself right now? And that is the 1.5. So we want to get rid of that 1.5. So this equation will just say x is equal to a number. So how do we get rid of that 1.5? Well, right now we have 1.5 next to an x. Anytime you have a number written right next to a variable, those two items are being multiplied against each other. So this 1.5 and the x, because they're written right next to each other, they're being multiplied. So in order to get rid of a number in an equation, you always have to do the opposite of what's happening. So if right now that 1.5 is being multiplied by the x, in order to get rid of the 1.5, we have to divide both sides by 1.5. All right, so on the right side, the 1.5s cancel each other out, and we're left with x by itself. And then we just got to do 150 divided by 1.5, and it equals 100. So now we can plug in 100 instead of x here, and we'll be able to see that it takes 100 minutes in order to fill the bathtub with 150 gallons. So our answer is going to be B. So let's go ahead and move on to the next problem. You guys are doing a great job keeping up. And I just want to let you guys know that there was a big question of probability. You guys were looking for probability questions. That's coming along in problem number 14. So just stay tuned, or you can go ahead and skip to problem number 14 if you want to see it. All right, so problem number 10. It says the volume of a right rectangular prism is found by multiplying the length of the base by the width of the base by the height of the prism. Okay, so all that is saying is volume is equal to length times width times height. That's all that is saying. And if you've been in math, even if you've been in math many years ago, when you see this formula written down, it may ring a bell. You probably have seen this before. Most students have, even if it's been a long time since you've been in school. So it's just volume is equal to length times width times height. So we're just going to go ahead and fill in whatever values they give. So it says the prism has a volume of 30 cubic inches. So instead of writing V, we can now substitute that for the number 30. Bring down the equal sign. And then it says the height of the prism is 6 inches. So instead of writing H, we're going to write 6. And we're going to do that times sign. And then it says, well, what is the area of the base? And so they're not saying what is the length or what is the width. They're asking for the area. Well, it's very simple. Length times the width is just equal to the area. So we're just going to write A for area here. So 30 is equal to area times 6. So what number times 6 is equal to 30? Very simply, the area would be 5. So our answer is going to be A, 5 square inches. That wasn't an easy problem, but when you just take your time and just write everything out, fill in the information that they give you, and then try to just use some outside knowledge of what you know. We've all done area problems. Area is length times width. So just plug in what we know, plug in the outside information, and then go ahead and solve. We're going to go ahead and move to problem number 11, but if you have any questions, please comment them down below. All right, problem number 11, it says Jacoby followed a recipe that requires 2 cups of water for every 3 cups of flour. All right, and it says, it seems like we're going to go ahead and make a fraction. It says if he used 8 cups of flour, how many cups of water did he use? Okay, so it looks like we're going to make more than just a fraction. We're actually going to make a proportion. And what we learned before is that anytime we're setting up a proportion, whatever we put on the top is what we put on the bottom. So it's a recipe that requires 2 cups of water. So I'm going to write 2 cups, and then I'm going to write W for water. And then on the bottom, it's 3 cups of flour. Just so I know it's the same measurement, but one's talking about water and one's talking about flour. And so then it says if he used 8 cups of flour, so how many cups of water did he use? Be very careful. I know that most students are going to go ahead and put 8 cups of flour on top, but you have to go ahead and look at that first fraction that you made. Water should be on the top, flour should be on the bottom. So we're not going to put that 8 cups of flour on top. We're going to go ahead and put it on the bottom. So 8 cups of flour. And we need to find out how many cups of water does he need. So we're going to put X on top for the cups of water. So now that we have our proportion set up properly, it's very easy to go ahead and solve. We're just going to go ahead and cross multiply. So we're going to do 3 times X, which is just 3X, is equal to 2 times 8. Okay? So 2 times 8 is equal to 16, is equal to 3X. How do we go ahead and solve this? Again, we're trying to get that variable or that X by itself. What's causing that X to not be by itself? It's that 3. What's happening with the 3 right now? The 3 is being multiplied by the X. So how do we get rid of that 3? We divide both sides by 3. So the 3's cancel each other out, and you're left with X is equal to 5.333333. Okay, so if you look at our answer choices, that's not the answer that we see, but we can just go ahead and guess that it's not 2, 4, or 12, but it's 5 1/3. Most of us won't be able to know that 0.333 is always representing a third of a fraction. So it's 5 1/3. If you didn't know that 0.333 equals a third of a fraction, you can easily just look at all the other numbers and say it's obviously not 2, it's not 4, and it's not 12, so it just must be the 5. All right, so we're going to go ahead and go to our next problem, and you guys are doing great by keeping up. I hope you're taking notes. I hope that you're trying to write down any questions that you have so you can let me know at the end of this, but let's continue on. So it's 4x, I'm going to just rewrite this, 4x plus 5 plus 4x plus 8. Now, being able to solve an equation is very important. These skills you're going to need to have. You're going to need to have this on your entrance exam, but if you take any type of math, if you're taking basic math or you're taking an algebra class in your college, you're going to need to learn how to solve equations. And so the same method that we were applying before in those other equations is what we're going to apply to this one as well. Our goal always is to get the X by itself. But before we can get the X by itself, this problem is asking us to do a few more things before that. So anytime I see a parentheses in an equation, I know that that's usually the first thing I'm going to have to handle. So there's a number outside of the parentheses, so I'm going to have to distribute. Distribute means take this 4 and multiply it by everything that's inside that parentheses. So first, I'm going to do 4 times x, which is 4x. Then I'm going to do 4 times 5, which is positive 20. And then I'm going to bring down everything else that's in the equation. Okay, one step at a time. That way, if you make any mistakes, you're able to track what you did wrong and you're able to correct it. If you don't write every single step, then sometimes if you make a mistake, there's no way identifying where you went wrong. You may either give up out of confusion or you may have to restart the problem all the way back to the beginning. So I recommend always writing one step at a time. All right, so now I'm going to look at this and I'm going to say, okay, 4x plus 20 plus 4x plus 8. So how am I going to go ahead and put this together? So I'm going to go ahead and combine like terms. So 4x and 4x, they're both like terms. The reason why I know that they're like terms is because they both have an x in them to the same power, to the power of 1. So I can go ahead and add them together. 4x plus 4x is 8x. And then I also know that the other two terms that are alike are just the numbers that are by themselves. 20 plus 8, which is plus 28. Now, my apologies. I'm now looking at it. They're not asking us to solve this, but they're just asking us to find which expression is equivalent. So we're basically doing the same thing, but we don't have to solve for anything. So my apologies about that. But now that we have an answer, 8x plus 28, we now have to figure out, okay, so this is not it. It can't be D. 5x plus 17, that's totally not it. We have to figure out if A or B is equivalent to 8x plus 28. So that means we have to now break down what we kind of like put together. But that's totally okay. So The way that you break this down is you look at 8x plus 28 and you ask yourself, what is the largest number that can go into the number 8 and the number 28? What is the largest number that can go into 8 and 28? So I'm thinking 4. 4 can go into 8 2 times, and then 4 can go into 28 7 times. So I'm going to pull out the number 4, and I'm going to divide each part by 4. So 8x divided by 4 is 2x, and then 28 divided by 4 is 7, and that is 8x plus 28 broken down. 4 times 2x plus 7, so my answer is going to be A. All right, so we're going to go ahead and we're going to go to problem number 13. It took Khalid, my bad. It took Khalid 90 minutes to complete 40 tasks. Which of the following is an equivalent rate? Okay, so we're talking about rates. We're talking about being equivalent. So again, we're probably going to set up a proportion. I'm so glad that they're asking you for multiple proportions. That way that we can just continue getting better and better at it. So we're just going to go ahead and do what we've been doing. We're going to set up two fractions set equal to each other. And so it says 90 minutes to complete 40 tasks. So 90 minutes and 40 tasks. So now I know that minutes has to go on top and tasks have to go on the bottom. It says, which of the following is an equivalent rate? So they want you to find something that has minutes on top and then it can have tasks on the bottom. So they want every single one of our answers has 10 tasks as the minimum. So that's what we're going to fill in to our answer, 10 tasks. Again, the reason why I chose 10 tasks is because every single one of the answers has the 10 tasks in them. So now we just want to figure out, okay, how many minutes will it take so we know which of these answer choices we will choose. So minutes are on top, tasks are on the bottom. We know we set the proportion up correct. So let's go ahead and solve. So the way we solve a proportion, yep, that's right. We're going to do 90 minutes times 10. So 90 times 10. And then we're going to go continue and cross multiply 40. And we're going to put x here, which is 40x. So 90 times 10 is 900 is equal to 40x. And we're going to divide both sides by 40 in order to get the x by itself. And the x is going to be equal to 22.5. So my answer is going to be D. 10 tasks in 22.5 minutes. So I hope you guys are feeling refreshed because our next problem is the problem that everybody's been waiting for. The probability questions, the questions that people have been looking for online. I know you guys don't get a lot of examples of probability. And I know that there are going to be questions about probability on your Accuplacer exam. And I also know that there's going to be questions about probability on your TSIA 2 exam as well. So I'm going to do my best to break this question down as easy as and simple as possible. But again, don't be intimidated by this. We're just going to think it through. All right. The table above shows a survey of 50 registered voters. Each voter was asked whether they plan to vote yes or no to do two different issues. So, if a voter who plans to vote yes on issue P is randomly selected. So, before I go any further, I'm just going to see if a voter who plans to vote yes on issue P. So I'm going to go to my chart and I'm just going to look for that information. Plans to vote yes on issue Q? Nope. Plans to vote no on issue Q. Okay, no. The top is not talking about issue P. So now I'm going to look on the left side. Plans to vote yes on issue P. Right here. Okay. I'm going to continue to look just in case. Plans to vote no on issue P. No. So we're not going to use this second row because they plan to vote no on issue P. But this information, we're trying to find yes on issue P. So we found it and we start here. Okay, so I know that we're going to be looking in this direction for these numbers. So plans to vote yes on issue P. The total amount of people who plan to vote yes on issue P is 20. That's good to know. But we start here on plans to vote yes on issue P. Now let's go to the second part of the probability. It says, what is the probability that voter also plans to vote yes on issue Q? Okay, so plans to vote yes on issue P is over here. So now we're going to look at above. Plans to vote yes on issue Q right here. So how many people plan to vote yes on issue P and plan to vote yes on issue Q? 8. 8 people out of 20 total people who plan to vote yes on issue P are also going to vote yes on issue Q. 8 out of 20. When you go ahead and do the division for 8 divided by 20, it's equal to C, 0.40. But I'm not going to allow myself to just say, okay, Miss Amber, you got it. Go on to your next problem. Because I know a lot of you are probably looking at me like, what in the world? And this is the question that I really want us to focus on. So if you are happy with that answer, go ahead and follow questions number 15 through 16. I'm still going to do those after this problem, but I want to spend a little bit more time on this question because even when I read it the first time, I was a little bit confused as well. So let's try another example that's going to be a little bit similar. So what happens, let's say we want to find, let me erase this, sorry. I want to find a voter that plans to vote no on issue P, but also plans to vote no on issue Q. Okay, so I'm going to first look for them. Plans to vote no on issue P. So again, I'm going to look at top. Plans to vote yes on issue Q, no. Plans to vote no on issue Q. Nope, I'm not starting there. That's not where I'm starting. I'm starting on issue P. So plans to vote yes on issue P. Nope, I'm not starting there because they're not voting yes, they're voting no. Plans to vote no on issue P right here because that they're planning to vote no on issue P. After I start on this first one, then I can go ahead to the next one. And now I also want to find the ones who plans to vote no on issue Q. So who plans no? This is, if we look above here, they plan to vote yes on issue Q, so that's not right. And if we look above here, this number, they plan to write no on issue Q. So ones who plan on saying no to P, but also yes, no to Q, are 16 people. You literally just follow it along. Go across here, and it runs here, and we end up with this number. So 16 people plan to vote no on P, but also no on Q. But you always have to put that number out of the total, which the total is 30. So it would be 16 out of 30, and then you would go ahead and divide 16 divided by 30, and then you'd be able to get the fraction, which is about 1/2, or if they ask you for a decimal, it will be 0.533333. So again, probability is a little bit confusing, but I know that we'll be able to do it. Just focus on the first part, find which row or column it is in, then find the second one, figure out what row and column it is, and then single out that one number of how many people who plan to vote on each, and then put that number out of the total, and that total is usually found going across where you started. All right, let's go ahead and go to problem number 15. It says, which of the following values is equivalent to 5 to the -3rd power? Okay, so exponents usually confuse a lot of people, so don't feel bad if exponents confuse you as well. It's okay. They confuse me sometimes too. The best way to deal with an exponent is just to remember the rules. Actually, the only way to deal with an exponent is if you remember the rules. So one thing I want to show you before we deal with the rules is when we have a number that's by itself. Say we have the number 5, the number 10, and the number 13. All of those numbers can be written as a fraction by putting it over the number 1. They're all written over an invisible number 1. Every single number that's by itself, every whole number can be written over the number 1, and that's how you could put it into a fraction. It's the same thing with 5 to the negative third power. 5 to the negative third power can also be written 5 to the negative third power over 1. That's just the rule of things. A whole number, any whole number, positive or negative, can always be put over an invisible 1, or it can always be over an invisible 1 if you want to put it over or put it as a fraction. The reason why I'm showing you this rule is so that when we apply the rule of exponents, it makes sense. So the rule of exponents is we don't like negative exponents. And I agree with that rule wholeheartedly because I don't like negatives in general. But we don't like negative exponents. It's hard to do anything with a negative exponent. So we try to get rid of that negative exponent by making it a positive exponent. The only way to make a negative exponent a positive exponent is if we flip where it's at. Okay, so right now, the negative exponent, the 5 to the negative 3, is on the top of the fraction. If we wanted to make it a positive 5 to a positive exponent of 3, we have to now switch where it's at. It can't be on the top. It now has to be on the bottom. So instead of 5 to the negative 3 being on top, we could put 5 to the 3 on the bottom. And because we switched where it was from it going from top to bottom, that 3 goes from negative 3 to positive 3. And we can go ahead and put that 1 on top. So 5 to the negative third power over 1 is the same as saying 1 over 5 to the positive 3. To 5 to the positive 3 power. Okay, so I hope I haven't lost you. I'm going to show you guys another example, but let's just get through this problem, okay? So now that I have this, I can go ahead and just figure out what this all means. 5 to the third power means 5 times 5 times 5. 5 times 5 is 25. And then 25 times 5 is 125. So this is saying 1 over 125. And so my answer to this question is going to be B. But my answer to your next question is, Miss Amber, like what in the world were you just doing? So let's go ahead and just show you one more time, and we're going to speed it up because I know you guys are going to catch on. So I'm going to have 3 to the negative 3 power. You remember that every single whole number, even if it has exponents, even if it's positive or negative, can always be written over an invisible 1. We know that we want to change that negative exponent to a positive exponent. The only way we can change it from a negative exponent to a positive exponent is if we change the place of it on the fraction. So if it's on the top of the fraction, we have to now put it to the bottom of the fraction. So it's going to be 1 over 3 to the third power. Now that we put it on the opposite side of the fraction, that negative 3 becomes a positive 3. And so now we can work with it. So now it just says 1 over 3 times 3 times 3. And so 3 times 3 is 9. 9 times 3 is 27. It will be equivalent to 1 over 27. And now you guys know how to work with exponents that are negative. You guys are doing great. Let's go ahead and move on to question number 16. Which of the following expressions is equivalent to x to the third power times x squared, and then outside of it is to the exponent of 5? Okay, so now again, there are other rules about exponents. And to make it easy on you, the only way you're going to be able to do it is if you just remember the rules about exponents. So it's very simple. Anytime you're multiplying values, multiplying letters that have exponents, then you go ahead and you just add the exponents together. So in this case, inside the parentheses, you are multiplying values that have different exponents, 3 and 2. So you would do x to the third power times x squared. That's equal to x, 3 plus 2. It would be x to the fifth power. Okay? So inside the parentheses now, I'm going to write x to the fifth power, and then we're not going to forget about this 5 on the outside. Okay. So now that we handled everything that was inside the parentheses, now we have to figure out what do you do with the exponent that's hanging on the outside? Do you just leave it, or do we do something with it? And the simple answer is that you just multiply the exponents. When it's outside of the parentheses, you multiply. So 5 times 5, which would be 25, it would be x to the 25th power. And so our answer is going to be C. If you understand this problem, then you can go ahead and say, bye, Miss Amber. I hope to see you guys again soon. But if you need another example, just wait just one moment and I'll be able to show that for you. So I'm going to give you something very similar. X to the second power times x to the 4, and then 2. So again, the rule is when you're multiplying exponents, what you're doing here, you're multiplying two values that have exponents. You go ahead and add those exponents. So it'll be x squared times x to the 4th. So it's just equal to x, 2 plus 4, which is equal to x to the 6th power. So we're going to go ahead and replace x to the 6th power in the parentheses, and we're going to put 2 on the outside. And now that we have a parentheses separating it, we're going to just multiply those two numbers. So 6 times 2 is 12, so it'll be x to the 12th power. You guys did fabulous today, and I'm going to go ahead and do the rest of the review for next time. Go ahead and like, save, share, subscribe, all the things. I appreciate you guys so much. Have a great rest of your day.